So hello, welcome, David Kaplan, a professor for educational psychology at the University of Wisconsin in Madison. Welcome to the German Youth Institute in Munich. You're here for a few weeks, working together with our teams on some statistical problems. And we thought this might be a great opportunity to talk a bit about your work and how about your work might inspire our analysis, our modeling expertise, our teams, and enhance our possibilities of reporting.
Mm-hmm.
So,
thank you.
Welcome.
Yeah, thank you very much. It's great to be here. It's great to be at the DJI in Munich, so it's a pleasure.
Have you been to Germany before?
Many times. Many
Okay.
times, yeah.
So you like staying in Germany?
I do, very much so.
Okay.
Yeah.
You know that the purpose of the German Youth Institute is mainly to do research with the ultimate goal of advising policymakers, advising the general public, providing evidence on youth and growing up in Germany, on how families are doing, on health development in kids. Has this played a role in your work so far, or can you describe a little bit how this impacted your work so far?
So I'm an educational statistician by training. So my work, my background, my education has been in statistics and in applied statistics, specifically in the social and behavioral sciences. At some point in the trajectory of my career, I started to work on problems related to large-scale educational assessments, in particular PISA, the Program for International Student Assessment, and in the United States, the National Assessment for Educational Progress. Just by virtue of working on those surveys and on those assessments, it's impossible not to be involved in the more policy aspects of it. And in particular, I found myself very interested in questions of prediction related to literacy competencies in young children and in 15-year-olds and teenagers, more or less teenagers. In particular, reading competency. So a number of the developments that I've worked on have focused on that as an outcome, but also on mathematical literacy as well. So the development of literacy competencies in young children has been the primary motivation for the statistical work that I've done, with the hope that the statistical developments can help inform the policy, and I don't know so much about practice, but certainly policy related to development of young children.
And is this a personal motivation, or is this just the kind of data that you like most for the statistical work that you're doing?
I think it's a little bit of both. I do think the topic of literacy development and competency development in young children is very, very important. It's certainly not the only thing that's important. Obviously, non-academic competencies such as social competencies and behavioral competencies are equally important. It just that happens to be what I've been focusing on. But there are so many interesting problems related to properly analyzing and being able to properly report the results of these large-scale assessments that, yes, it's a little bit of both. I'm interested in it because it presents really interesting statistical problems, and it does have some bearing on a very important problem globally.
So a lot of the work that we're doing here is not with the only focus on education, but it's a lot on, let's say, inequality matters, on social educational aspects. Would you say that your work also targets topics of, let's say, poverty and inequality in childhood and youth?
Again, I think probably indirectly. The direct applications are towards education, but if you think about this in the context of the UN Sustainable Development Goals, these are all highly interrelated.
Okay.
Right.
Yeah.
So gender equality or inequality, as the case may be, ending poverty, goal 4, which relates to education, all of these are sort of foundational goals that are very highly interrelated, and what is most important and what is first is probably debatable. But at the end of the day, I think that focusing primarily on what I do, which is education, to a certain extent the studies I've done have looked at gender differences in certain educational competencies, relates to, and also at the international level, looking at the development of competencies in countries at the country level that differ from other countries in terms of their economic resources. I think it's all sort of tied together. I'm not looking so much at student level questions of poverty, but more national questions of poverty.
That's where the link to policy advice
exactly.
is. Right. Okay.
If possible, yes.
Would you say that there's one finding or two findings maybe that were most surprising to you, where you say didn't expect that, or where some methodology that you applied brought out a certain finding that was not possible before that, or kind of surprised you most?
Surprising until I sort of thought about it, then maybe it wouldn't have been after the fact all that surprising. I would have thought that I would have seen in one study that we're kind of wrapping up now, and I know that there is different views about this depending on the data sources you look at. I would have expected to see what we see in reading is this typical gender difference between boys and girls at the country level, by the way, in which the girls are outperforming the boys by a little bit. But nevertheless, it's consistent. It really is quite consistent. I thought I would see the reverse, the sort of assumed male advantage, at the country level, not any individual kid, but at the country level, and the lines are practically lying on top of each other for math. For reading, you see it. And so the math result, as far as we can tell, that was a little surprising to me. The other thing was how much the boys and girls track each other in their trajectories at the country level. So in other words, countries whose performance in reading, the percent of the children that are below minimum proficiency in reading and math, the lines for the boys and the girls are parallel, right? And they're literally parallel. So I might have been a little surprised about that. I would have thought that maybe I would have seen a little bit more divergence. They're catching up. If anything, the story that I'm seeing in my work is that we're kind of achieving the wrong kind of gender equity. In other words, the girls are catching up with the boys, but not in the direction one would hope. Yeah. So I don't know if I would call that necessarily surprising. I was dismayed by it, but it is tracking that way. And these are empirical. These are not model-based predictions of what's happening. This was just actually plotting the empirical points for a fairly large subset of the countries that participated in
over some period
PISA.
Of time.
Yeah, from PISA 2009 to the 2022 assessment.
Okay. So if that's your empirical estimate for the point estimate for the empirical distributions that you have in PISA, how would you say that the kinds of model classes that you're using or the types of statistics that you're using enhances of what is possible to take politicians by using your type of techniques?
The interest that I have here is in forecasting. Okay, beyond the PISA 2022.
So where countries are going.
Where countries are going. You want that forecast to be optimal in the sense that it is calibrated to what actually has occurred. And what that means is that you're not going to get a perfect forecast. It's not like you're going to say, well, what's going to happen in 2025 is this and it's going to happen. But rather, amongst a variety of different ways that you can do the forecast, this one will be better calibrated to what's going to happen by virtue of how it was estimated on what had already happened. So in that respect, what I think you can do is provide policymakers with optimal forecasts. And that's what's sort of new about the work that my colleagues and I have done, is we're showing a methodology that provides better forecasts. An analogy that I use often when I'm teaching, but also when discussing this with colleagues, is weather forecasting. Because in fact, we're using a lot of methods that are very similar to and developed from, in fact, in many cases, weather forecasting, which is you want to know what the weather is going to be like tomorrow. You're getting this information from a large number of sources on the ground, satellites, and so on. The way in which you combine that information is going to give you a forecast for what the weather is going to be tomorrow in a particular region, right? That doesn't mean that that's what's going to happen, but if you do it right, it means that the method you're using is going to be right more often.
Yeah, right.
Better
right.
calibrated is
right.
what we mean to the actual events that are going to be taking place. We're using very similar methodologies, but applying it to, in this particular case, the trajectory of where countries are going with respect to meeting the sustainable development goals in education.
So then actually a country comparison is a very helpful tool for these kind of methods, because you have the different countries with the different trajectories across time, which you're then applying.
That's right. And let me add one more thing. The methodologies we use also do not treat the countries as totally separate entities, as though the information from one country isn't valuable for the information of another country. The procedures, which are quite technical, but the procedures combine information and use and borrow information across all the countries to provide the best estimates possible for a particular country.
So
no information
that is actually
wasted.
an advantage, because a lot of times the 16 federal states in Germany make it more difficult for reporting, because you can always say there's a certain policy in place in 2 of the federal states, but not in all 16 of them. We have 16 different educational systems, you could even call it. And so that actually your statistics might be most helpful with this comparison to have like individual trajectories for the individual federal states, but also one for all of Germany in general.
That's right.
Right. Did I understand that correct, that this work, if you say it's related to the Sustainable Development Goals, is also relevant for predicting when certain standards are met or when certain criteria are fulfilled?
Yeah, I mean that the United Nations SDG 4.1.1 talks about meeting or exceeding minimum proficiency. Minimum proficiency is defined as the PISA level 2 competency. So I can set that as the criteria. I can calculate at any given point in time the percentage of, and for those who participated in PISA, the percentage of those kids at or above, or at or below, depending on which way I want to look at it, that have met that goal. And so what I'm doing is that's the outcome I'm tracking. So I'm tracking the percentage change over time. The idea being that you would like 100% of the students to be above, right? With no gender differences in that, by the way. That would be gender equality then. That's what I'm tracking. So yes, there is a defined standard. In this particular case, there's a defined standard. Clearly, it's arguable, but that's what's being used, and it's PISA level 2. It's the only international assessment that's being used specifically in the context of
age group,
SDG 4.
Right. Typically, when we write our reports, we're working with frequentist methodology. So something that is very easily transferable to the wider audience, wider public, for example. We have point estimates for distributions, like averages, the means, the median, and so on. What would change in this kind of reporting? What would change in the way we could inform politicians and practitioners if we would apply Bayesian statistics to all these reports?
Well, I think that it wouldn't be easy, because if policymakers are in fact used to seeing results presented, let's say where you're doing comparisons, and those comparisons are reported as binary significance tests, that would not be present in those reports anymore, not necessarily in the same way, for sure. So there's no suggestion it would be an easy transition, but what would be gained is a more nuanced conversation about what is important Okay, so significance testing, in the classical sense, would just simply, if it's done right, would be giving you a binary decision, and there's not much you can act on with a binary decision. It's typically a binary decision, incidentally, around averages, the mean or the median, right? But there are other parts of this distribution of outcomes, whether they're social emotional outcomes or whether they're academic outcomes, that might be of very specific interest to policymakers that are not the mean or the median, but maybe in the tails of the distribution.
Yeah, like the group that's not meeting even the minimum standards or something like that.
So the question would be, what is the probability that the policy is having an impact in various parts of the distribution? And that's, again, a more nuanced conversation to have. And that is a conversation that you cannot have if you're doing this as a frequentist analysis. It would be very, very difficult to do because it's not what frequentist statistics is actually presenting for you. The other aspect of this, which I think would make it very difficult, but not impossible, is that policymakers would have to get used to the idea of what it means to quantify uncertainty. And so there's two types of uncertainty, right? There is frequency uncertainty in the sense that if I'm observing weather every single day of the week, my forecasts are all maybe not quite right? There's frequency uncertainty, sampling variability, and so on. But then in Bayesian statistics, there's this idea of epistemic uncertainty. And epistemic uncertainty is sort of not knowing what you don't know, or admitting that you don't know something. It results in a different kind of framework for thinking about what it means to be uncertain, right? So an example that I like to give is the example of imagine that I am going to bet on whether Germany is going to win the World Cup, okay?
We all have a bet on that, but...
That was very important what you just said, that we all have a bet on this, right? I might bet on it simply for emotional reasons. I want Germany to win the World Cup, let's say. I know nothing about the team. I know even less about football, but I'm very interested in making sure, I really want to bet that they win. You, on the other hand, are extremely knowledgeable.
You think so?
Let's just say that you are. I think you probably are. And so you know about the various issues that are going on with the team, financial problems, interpersonal problems, all of which could affect the outcome of the game. Notice that the record of wins and losses are exactly the same for you and me.
Right.
But the information that you're bringing to bear on this is not the same as the information, could be quite different. I would presume mine would be quite a bit less accurate, but nevertheless, it would be different. So the difference in frequentist statistics is that all you're working with is that past information of frequency, right? Whereas Bayesians would say that's important. We can't ignore that past information, but we can use it to inform our epistemic knowledge of what to bet on, in particular, how much to bet. Because if I know how much you're betting, I know a lot about what your personal epistemic knowledge happens to be, right? Or at least I believe that I do. Getting policymakers used to the idea that there is this other kind of uncertainty that factors in, and in particular, that if there's a sensible way to deal with it, our predictions are then better calibrated. And the reason is that that uncertainty is going to be there whether you like it or not.
So it's a lot about transparency.
It's exactly about transparency.
In your documentation pretty much as well.
Right. But now it's statistical transparency. You're allowing the model to understand what it is you're bringing to the table, right, in terms of its analysis of the data. That's what makes Bayes actually different from frequentist statistic. There's a lot of other math and magic that goes on, but at the end of it, you are provided then with a estimate that incorporates this level of uncertainty, and at the end of the day it's not guaranteed to, but can provide, in principle, your inferences and your forecasts will be as good and often better than other ways that you could have
You
provided
probably
those
even
forecasts.
might be able to draw other conclusions, right? Or conclusions to. I'm going to repeat that real quick for noise reasons. Probably from what you're explaining, I would assume that it might even be possible to draw other conclusions. So taking into account that some of the analysis are different, that some of the reporting is different. Is there anything to say about the different kind of information that we deliver politicians?
Well, this is again where I think bringing a Bayesian perspective into this, while it has a lot of benefits, as I said earlier, I don't think it's that simple. And one of the reasons is you can and legitimately should question that knowledge, that epistemic knowledge, because as I said, you and I have different perspectives about that team, right? And so a policymaker could rightly say, well, how much of these results are based on your particular biases as they have entered into this Bayesian analysis, and how sensitive are those results to your specific viewpoint? Did you ask somebody else what their particular viewpoint is? So that's a totally legitimate issue, and the question then becomes, are your results sensitive to those epistemic choices? Now, in the way in which a Bayesian would deal with this is they would say, okay, what we're going to do is we're going to make that information, that knowledge information, as non-informative as possible. In other words, try to eliminate as much of that bias as possible and let the data do most of the talking here.
You
right?
probably need large sample sizes for that, right?
Well, if you do have large sample sizes for that, you're in a very fortunate place, because then the sample sizes will swamp, if you will, or take over what your biases may be. So from a Bayesian point of view, there's two sources of information. One source of information comes from the data, namely how big your sample size is and the quality of the measurements and so on. That's information coming from the data. The second source of information comes from your epistemic knowledge, previous studies, expert opinion, and now the two of them, the Bayes theorem, balances this information. Well, if you have a very large sample size, and let's just say for the sake of the argument, an infinitely large sample size, then no amount of your prior beliefs matter. It's all there.
Overruled, right.
On the other hand, the opposite happens. If you have very small sample sizes, suddenly the results are going to be quite sensitive to that epistemic knowledge that you bring in. And there's where the sensitivity analyses become very important, because now what you want to do is see just how sensitive the results are to that particular choice relative to the amount of data that you have in your hand. The other possibility is very important as well. What if you have very small amounts of data in the form of a sample size and very weak theory or very weak epistemic knowledge? Interestingly enough, that's an honest assessment of where the field is or where you are in your particular research program.
Right.
And it's telling you that. And how is it telling you that? The intervals are wide, indicating you really don't know. So we think of this, Bayesians think of this as honest, right? And so the question then becomes, can you get a bigger sample size? Or can you get more knowledge? And you build iteratively more and more refined, narrower intervals around the quantities that you're actually interested in.
So that from your point of view, one aspect or one criteria for high quality policy advice then would be to be honest about your assumptions, be transparent about the quality of the data, the prior information that you have.
That's exactly right.
How would you put all this in a report? Imagine being a politician working in Berlin. You probably work in a ministry, have a range of different topics, and maybe have 2, 3, 5, 15 larger projects reporting to you. And you need to take in all these reports, all these results. What would you say is the most difficult thing in conveying results do policymakers?
They're not going to be binary decisions. I think that's the most difficult thing. It really requires, I think, a conversation and sort of retraining. I don't know if I want to call it that necessarily, but kind of a consciousness raising, that it isn't going to be a binary conversation anymore. And I can certainly appreciate why policymakers might want to do that. There's an emergency. There's clearly some societal problem. We really need this intervention. My worry, and I guess I can afford to be worried about this, I'm a professor, I'm not a policymaker, and I appreciate that difference, but I suspect that what I would worry about is policymakers making policy decisions on the basis of binary information that is not well calibrated to what would happen when you scale up the policy. So I keep coming back to calibration, which interestingly is a frequentist idea, but I'm very concerned about the calibration. Right, when you decide to scale up an intervention, how is that going to work? And you don't get the nuance from a frequentist approach to this to be able to tell how this is going to scale up. Not suggesting that the Bayes will tell you how it's going to scale up either, but you have more questions you can ask around the scale up question than you would in a frequentist point of view. So I understand the pressure. I totally understand the rush to have a certain kind of answer. I would worry about scalability. I would worry about calibration. And Bayes is set up to be, if done correctly, there's a lot to it, but if done correctly, it's set up to at least support those kinds of questions that policymakers might ask.
So what you're suggesting is actually almost like a philosophical change in reporting, right? Because it requires us to rethink, to use different kind of models. It requires politicians to be aware of uncertainties, of the way that you're handling the data, the way they came to the results. How difficult would you say is it for, well, the research groups to really change to different kinds of reportings?
On a practical level, probably not very difficult at all. I mean, you can certainly supplement Bayesian estimates with graphical displays that would convey the kinds of things that you're interested in. It would require that research teams become familiar with Bayesian methodologies. It would also, because there's enough new to Bayesian statistics that really requires either workshops, professional development, or full-blown courses, right? And so it's not just simply pull down a menu in a software package and push a button. There's some decisions that need to be made, but there's no reason, why that can't happen if there's an interest in it and if there's an investment in the training of researchers. But these researchers are coming from undergraduate and graduate master's programs and so on. And one of the things that we know, and it's still more or less the case, Bayesian statistics is not taught, at least at the undergraduate baccalaureate level, as a formal course in its own right. Typically, you'll hear about it maybe in an introductory stat course, but it's usually just mentioned in the past without any real development about what that is, and you forget about it 5 seconds after you heard it, right? And there was a reason for that. For the longest period of time, there was just no software or computational ability to do it. And then, of course, there's the controversy around significance testing and the concerns about, what would life be like if we didn't have significance tests, right? So there's controversies around this. Those are really going away. We have the computational machinery. It can be slow sometimes, but we have the computational machinery, and people are beginning to slowly realize the benefits of it. But that's typically benefits of Bayesian statistics. But that tends to be after they've already had their undergraduate, in many cases their graduate training. And so they're picking it up either at workshops, on the fly, books and so on and so forth if they can. And that's a little bit hard. It would be nice if there was a way to incorporate that into formal training. But that's hard to do in one
like
academic...
mother tongue Bayesians.
Yeah. Yeah. Yeah, exactly. Mother tongue, Muttersprache?
Muttersprache.
Muttersprache, thank you. Yeah, that was it. The reports themselves, yeah, they might look a little bit different. The graphical displays might look a little bit different, but it would be a different form of communication for sure. Yeah.
Now let's get back to the German Youth Institute. You came here probably because we've been in contact before. You've been publishing several years back already, and we do have quite a diverse set of data sets here at the German Youth Institute. We have very large data sets, we have cluster data sets, we have linked data sets. A lot of the studies that we're running actually are thinking about small groups, minority groups, groups that are difficult to reach. Is there an advantage of one or the other if you want to think about Bayesian statistics, or is it just as easily applicable to either kind of study, as long as you're in the quant?
Yeah, well, let me. I don't know if this is exactly the answer to your question. Let me make sure that it's clear that Bayesian statistics does not represent a new set of tools. It's the old set of tools, but done from a Bayesian perspective, this Bayesian epistemology, right? So there are procedures that one can use to estimate these small groups that come from the frequentist paradigm. And any kind of study that might compare the frequentist paradigm for doing these kinds of estimates of small, hard-to-reach groups might end up giving you more or less the same point estimate as you would get if you used Bayesian methods for doing this. It's just your uncertainty around it might be different.
Okay.
That's the key feature, is that the frequentist approach will not give you the uncertainty estimate. So sometimes students will say, well, wait a minute, isn't that what the confidence interval is? And the answer is no, that's not what the confidence interval is. The confidence interval is simply telling you, if you were to repeat this study an infinite number of times, how many times would that estimate be covered by that interval. They're not the same thing. So the Bayesian interval is really an uncertainty estimate, which is it's telling you what is the probability that that estimate lies in this particular interval. And even though that sounds quite the same, it just sounds the same, it's actually quite a bit different. And so you get more honest, I should put it that way, honest uncertainty intervals around the estimate that you're providing for that small area. That would be the advantage. The point estimate may be very, very, very close.
So this sounds like we can learn a lot from you while you're here. What is in it for you?
What's in it for me? Interesting research problems tied to substantively really important issues. Child development. Not just competencies. I know that the DJI has the AIDA study, which is not even about competencies. It's about the lives of kids growing up in Germany. And so that's a fascinating data set. Fascinating data sets that are developed by incredibly smart people who know the content area usually result in very interesting statistical problems. And I am applied statistician, so I'm interested in that bridging, if you will, of statistics, straight statistics, with an application problem such that maybe there's something that's already on the shelf that could be applied. If so, great, especially if that advances the field. But also the possibility that something has to be slightly tweaked, right, to be valuable to a peculiar data set, right, that advances statistical theory and the substance of the problem that it's being applied to. That's what's in it for me. So apart from being with my friends.
So the plan really is to listen in to most of the research projects here and see whether something that can be applied and whether you can develop further our analysis and the way that DJI is thinking about things.
Exactly. That's what I hope to do.
Well, we're looking forward to that. Thank you very much.
Thank
it was
you.
a very interesting conversation.
Thank you.
And I hope you have a great time here in Munich. And
no doubt.
You're welcome back anytime.
Thank you so much.